The PWM is a cool technique in which we can generate analog results, means an analog voltage by digital input, right? So we give a digital input and we generate an analog voltages on particular pin on Arduino. Arduino allows us to implement PWM in several different ways. The question is where it can be used. Let me give you one example. We have seen very often to turn LED on and off. But then what if we don't want LED to turn on and off? Rather, we want precisely control the brightness of an LED. And this can be done with pulse width modulation. It is also referred to as a PWM. Using PWM, we can control the duty cycle of a clock, which in result control the brightness of an LED or light. Let's look at a picture where we can see like what is a clock frequency, okay, what is a clock and what is a duty cycle. So if you look at a clock frequency on my screen, you will see this is in period of a clock, okay, and this is a pulse width. Now let's understand even more. Okay, so what is a period of a clock? Period of a clock in this image, it is represented by T cycle. Okay, it's a clock cycle. So if you take any clock frequency, you can consider one clock cycle. Okay, and clock cycle, that is a T cycle, is in composition. It is in combination of T on and T off, right? It means the amount of time your cycle stays high, it means active, and amount of time your cycle is off, it is inactive. Now this T cycle, that means a period of clock, is determine the speed of our microcontroller. This clock is represented as a clock cycle, as I said earlier, which is an amount of time in which two pulses of an oscillator, that is T on and T off. The duty cycle is a fraction of time in which the signal is active. So when somebody says a duty cycle means amount of time in which you are the T on, that means amount of time in which your clock remains active, remains high. So in Arduino, PWM frequency is 500 Hertz. That means the period of a clock is 2 milliseconds, right? So you can see the Arduino's programming language make PWM very easy to use. Arduino supports a function called analog write, which takes two parameters: duty cycle and the pin number. So duty cycle is a value between 0 to 255 because the PWM function in Arduino, means PWM feature in Arduino, is a 8-bit. So if you say 2 raised to 8, because it's a 8-bit minus 1, 2 raised to 8 minus 1 is equals to 256. That is from 0 to 255. And about pins, we will have a PWM pins on Arduino. Pin number 3, 5, 6, 9, 10, 11. These are the Arduino pins which supports a special feature called PWM. Now one thing you have to note in PWM, the PWM in Arduino doesn't provide any control over frequency. Even if we name it the function as an analog write, which takes pin and duty cycle, two parameters, the output is a digital signal. So when you pass a value into analog write, what we get out of this function is a digital signal, which is often referred to as a square wave, right? We have talked enough. Let's implement it in a live project where we will change the brightness of an LED, which is connected to pin number 9 of an Arduino Uno. Let's connect a red LED to Arduino pin number 9, which supports PWM function. Make sure we connect longer leg of an LED which will connect to pin number 9, and the shorter leg of an LED will connect to the ground. Let's start writing a code. I will start by writing analog write function, and then I will pass the pin number 9, and then 64% is the duty cycle, and then I will say delay of 1 second, that means 1000 milliseconds. Then we have to say analog write again, and this time again the pin number is 9, that's where the LED is connected, and we will pass 127 duty cycle, again the delay of 1 second. Okay. And what I'm going to do is, instead of typing this all the way through, I will copy this function. Okay, and then we will going to write analog write pin number 9, and then duty cycle will be 191 for 75% of the brightness, then delay again. So we will going to increase the brightness after every 1 second, and then we'll see if we can create a dimming effect onto an LED connected to pin number 9. So I will put the delay again for 1000 milliseconds, and then this will be, in the end I would going to say duty cycle 0%. That will turn off the LED, and then it will take 1 second of delay again. So if you look at this code, this will turn on the LED with the brightness of 25% brightness of an LED. After 1 second it will be 50% of the brightness, then 75% of the brightness, then it will increase 100% of the highest brightness, and then by writing a 0% duty cycle it will be turned off. So if I upload this program, you can perhaps see the dimming effect onto LED connected to and pin number 9, which is a PWM pin. You can also say it's a brightness control applications. We can control the brightness of an LED by generating a different analog voltage on the pin number 9. So I hope you will find this video educational and entertaining. I hope you understand how the PWM function works. We will see in the next video. Thank you very much.